En sommer vandrer om natten.
I have this freedom, but what I would like to know, and you started this discussion, if I really have this freedom, why should I be using original equation? I would like to know what the equation is within the new frame. Can I do that? That was done by Cartan, as far as I know. So what we say is we have this relationship. So we take a time derivative, use the chain rule, this is time dependent, g dot times the coordinate in the frame plus g times x dot. Now this is the guy I want to know, right? I know the velocity in my big world, and I would like to know what the velocity is in this world. So I have relation g dot x plus g velocity. So that's velocity in the plane. You okay? Good, okay. So this is group operations, so I'm allowed to write an inverse. So I write g minus 1 v at point x is g minus 1 g dot at the new point plus velocity at point x. Then I use this relationship and I'll write this as g minus 1 v of g of x is inverse operation time variation of the group of the moving frame dot x. Now here I use equivariance. The law is invariance, so this is v, and I get the new law of motion that says the velocity in my frame, could I put hats here and everybody's happy? If you're happy, I'm happy. It's trivial calculation. These are the ones that always kill you. So now what is this thing? This has a name. G dot is you take derivative t a, and this is summed over, theta dot. And as this is exponential, you get the group element here. And I might have done something criminal for non-abelian groups, but if you will trust anything I say, just go on. So that means that this object here, but what is this object? This is the tangent. If you remember from the last time, whenever we have a group orbit and we add x, then the tangent here is given by this Lie algebra element plus the velocity in the direction in the space. In other words, what we have done is we are here on a manifold. That's this point x hat. So we have a manifold, and the full velocity points out because it's in a full space. So this is full velocity. But it has two components. One component is this one. The tangent is pointing here. So there is a velocity which is normal to the fiber, which is this part, which is phase velocity times that. So this is phi dot theta. This is how are you moving around here. And then there is the other guy, which we call v hat. And this one by construction stays in the space. So that's the change of coordinates. The original thing was in a full space, it's blue. Now we have chosen new coordinates in which part of it moves along the fiber and the rest moves transverse to the group fiber or group orbit. This is not enough. You have to specify which frame to get a rule for computing phase velocity. You will move in this little space and you will integrate phase velocity at every fiber, and that will tell you where you are in a big space. But indeed, we have to give an equation for phi dot. And that we do not know because we haven't specified what moving frame we are in. So this is totally general. This is all expression of freedom. We haven't acted responsibly yet. Time to close the shop for today. Current version is total disaster in the book because we wrote it in 4 or 5 years ago, and we have learned lots of since. My lectures are better than the book, I hope. Well, the book is even worse than my lectures. My humble lectures.
Det er bare fordi, vi gerne vil have slukket lyset i salen. Så når vi ikke kan se jer.